Welcome, class, to the Intro to Java Programming. In this lesson, we will review inheritance, one of the major building blocks to object-oriented programming, along with how it works, accessibility, and some code examples. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we'll focus on inheritance. Inheritance is the mechanism by which an object acquires some or all properties and methods of another object. It creates a parent-child relationship between two classes. Yes, this definition is a little vague until you better understand the true meaning. Let's start with an example that covers an overview. Inheritance is accomplished by taking two classes and connecting them together in a parent-child relationship. These two classes can be called the superclass and the subclass. The superclass is the class being inherited from. It is often referred to as the parent class or the base class. The subclass is the class that inherits from the superclass. It is often referred to as the child class or the derived class. When declaring the child class, there is a class name like goblin and a keyword extends used to inherit the monster class. Both classes should follow all the rules of encapsulation. The parent class could have private constructors, properties, and methods. And the parent class could have public constructors, properties, and methods. The parent class can access all of its public and private properties and methods. The child class could have private constructors, properties, and methods, and the child class could have public constructors, properties, and methods. The child class can access all of its public and private properties and methods. The child class can access all the public constructors, properties, and methods of the parent class. The parent class cannot access any constructor, property, or method of the child class. If the parent class has a required constructor, the child constructor can call the parent constructor with the keyword super. The call to the parent constructor must be the first line in the child constructor. Let's imagine there's a game control class that can instantiate the goblin child class. It can access all the public properties and methods of the goblin child class, and it can access all the public properties and methods of the monster parent class. Correct, it is encouraged to avoid the use of public properties. However, if there were public properties, the game control class would have access to those values. One purpose of the parent class is code reusability. Remember, one of our goals for object-oriented programming is dry. Don't repeat yourself. Inheriting a class that has code we need is one way to reuse existing functionality. It is common for several classes to inherit the parent class and utilize existing code. For example, let's say the parent class has a public method called isSleeping. All monsters will have a 10% chance of being asleep. Let's say the result is false for this example. When the game control class instantiates the goblin child class and calls the isSleeping method, the value false is returned. If the game control class instantiates the skeleton child class, which also inherits from the monster class, and calls the isSleeping method, the value false is returned. The same method from the monster parent class is used by both child classes. This is one example of code reusability. Remember, the game control instantiated the goblin child class. The goblin child class inherited the monster parent class and has access to all the public methods of the monster parent class. This means the game control class can access the public monster parent class method through the goblin child class. The command child.isSleeping will return false. Another example of code reusability is a monster parent class method called getMonsterName. For this method, the value defaultMonster is returned. When the game control class calls the goblin child class for the getMonsterName, the value defaultMonster is returned. Each child class can override the parent method to perform custom behavior like returning a unique name. In the child class, create the same method name and signature. Above the signature, enter an annotation @override. This annotation is not required but very helpful to other developers as a clue the method is overriding a method from the parent class. Inside the code block, let's return goblin. Now, when the game control calls child.getMethodName, the value goblin is returned. The skeleton class could override the getMonsterName method and return skeleton. You can instantiate the parent class, but it's very uncommon and typically an indication of poorly designed code. Let's take a look at this example. Game control instantiates monster with myMonster equals new monster. This is just encapsulation. To use inheritance, instantiate monster with myMonster equals new goblin. Now the variable name myMonster instantiated the monster class with the goblin class as the child. MyMonster can only access public properties and methods of the monster parent class. MyMonster cannot access any properties or methods of the goblin child class. Can you access the goblin child class and methods if you instantiate the monster parent class? With the use of casting, you can access the public properties and methods of the goblin child class. Again, this is uncommon and typically an indication of poorly designed code. With this command, you can cast the myMonster variable as a goblin class. Then you will have access to any public properties and methods like getMonsterName from the goblin child class. Let's look at the code for inheritance. Open the OOP intro project in IntelliJ, close any open class tabs. Let's create a new Java test package called inheritance. Let's create a new class inside the inheritance package. Let's call it Goblin Inheritance Test. Let's make some space. Copy in this first test. Import any classes if needed. This first test will check public and private properties in the parent class. A new Goblin Inheritance object is instantiated as the variable name parent. Please note that the data type is a monster inheritance class. The value from the parent public string is stored in a variable called actual. The next line asserts the value matches the expected result. This line holds the value from parent private string. There is no test because we know this line will generate an error. Private properties cannot be accessed. The parent class is not allowed to access properties of the child class. This line will generate an error. On this line, with the use of casting, the child public string can be stored in a variable called actual. This line asserts the value matches the expected result. And this final line proves that even with casting, the parent cannot access a private property from the child class. This test will check public and private properties in the child class. A new Goblin Inheritance object is instantiated as the variable name child. Please note the data type is a Goblin Inheritance class. The value from the parent public string is stored in a variable called actual. The next line asserts the value matches the expected result. On this line, with the use of casting, the parent public string can be stored in a variable called actual. Casting the parent property is redundant and not needed. The child class can see the parent public properties. Casting is not required. And this line will assert the value matches the expected result. The child class is not allowed to access private properties of the parent class. This line will generate an error. The value from the public child string is stored in a variable called actual. The next line asserts the value matches the expected result. The child class is not allowed to access private properties of the child class. This line will generate an error. This test is very similar to the parent property test, except this test will show examples for the parent methods. A new Goblin Inheritance object is instantiated as the variable name parent with the data type monster inheritance class. We will prove the parent class public methods are available. The parent class private method is not accessible. The parent class is not allowed to access public methods from the child class unless casting is used. And the parent class is not allowed to access child class private methods, even with casting. This final test is very similar to the child property test, except this test will show examples for child methods. A new Goblin Inheritance object is instantiated as the variable name child with the data type Goblin Inheritance class. We will prove the parent class public methods are accessible. Casting the parent public method is not required. We will prove the child class public methods are accessible, and the child class private methods are not accessible. Let's create a new Java package called inheritance. Let's create a new class called Monster Inheritance. This is the parent class. There are 3 properties, 2 private and 1 public. This is a constructor used to set the monster name. These are the public getter and setter methods for the private property. These are 2 other methods, 1 public and 1 private. Let's create the child class next inside the inheritance package. Let's call it Goblin Inheritance. In the class declaration, use the keyword extends to inherit from the monster inheritance class. There are 3 properties, 2 private and 1 public. This is the constructor used to set the monster name property. Super will call the constructor of the parent class and pass the monster name. Super must be the first line of the child constructor. Other child class constructor lines will follow. Here the property for monster name in the child class is set. This method will override the parent class. These are 2 other methods, 1 public and 1 private. This method proves all the public and private properties and methods from the child class are available. These are the child methods. Notice there's no compiler errors. These are the child properties. Again, notice there are no compiler errors. From the parent class, only the public properties and methods are available. The private properties and methods are not available from the parent class. The value from the overridden child class is stored here. The value from the parent is explicitly requested and stored here. And overriding private methods from the parent class is not allowed. Let's comment out these 3 errors. Let's go back to the test class. There are several compiler errors. All of them will prove accessibility issues with the parent and child class, as noted before. This test will verify the parent object variable cannot access parent private properties or any child public and private properties. These 3 lines prove access is not allowed. Let's comment them out. This test will verify the child object variable cannot access private properties of the parent and child class. These 2 lines prove access is not allowed. Let's comment these lines out. This test will verify the parent object variable cannot access parent private methods or any child public and private method. These 3 lines prove access is not allowed. Let's comment these lines out. And this test will verify the child object variable cannot access private methods of the child class. This 1 line proves access is not allowed. Let's comment this line out also. Let's run these tests to prove property and method accessibility. This test passes. This test passes. This test passes. And this test passes. Here's a summary of all the test code we wrote in this lesson. You should now have an understanding of inheritance that connects 2 classes, a parent and a child, together with the extends keyword. Both classes should follow all the rules of encapsulation. Accessibility for each class was covered. And a common purpose of the parent class is to hold reusable code for other child classes. In the next lesson, we'll discuss abstraction with the abstract class. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!